So this next video is going to introduce you to a problem type that's a really important problem type in the Chapter 10 canon, which we're going to call a swinging bar problem. But that's just what we're going to call it. That's not all it is. So let's take this back to the easiest thing to think about, which is just the simple pendulum, right? So the mechanics of the simple pendulum is something at this point you should feel really comfortable with. I could ask you a whole bunch of problems, like if I started here, how fast is it moving here? I think obviously you would just do a conservation of energy, because we know that the path that it's moving on is a circle. We know it's not moving at a constant speed. We know that it's not moving at a constant acceleration. So we can't do kinematics with this. So we would just do conservation of energy from here to here in order to figure that out. Once we knew that, we could easily do things like what's the tension in the rope, because if I know at this point, I know the tension up minus Fg downwards is equal to mv squared over r, or if I had it at this position, it'd be the tension of the rope inwards minus the y component, or the radial component of the tension, or the gravity outwards, would be equal to mv squared over r, and I can find the tension. So this is a system that we should feel super comfortable with. But now that we're not dealing with point masses and we're dealing with extended bodies, this problem becomes a lot more interesting. So the swinging bar problem. Rather than having a pendulum like this, if I have a bar that's swinging back and forth, this is what I want to know about. I want to know about things like how fast is the object moving, which is a difficult question because how fast is what part of it moving? Because it's going to be a different answer if I'm asking how fast is this point moving versus how fast this point's moving versus how fast this point's moving. Unless there's some way to holistically describe how fast a rigid object is moving, I could ask about what the angular velocity at any point is, right? So swinging bar. But a swinging bar problem is not just a swinging bar, because once you understand the basics of the swinging bar problem, then we can do, I don't know, a swinging t-square. Or we can do, a swinging bottle of Lysol bleach, whatever it is. If you know the mechanics of how the bar functions, and we talk about how we extrapolate it outwards into other systems, you can see the commonalities, so then you can see it's just detail work from there. So in the next video, we're going to work our way through the swinging bar problem. And actually, we're going to have a couple of videos on this, each focusing on a different analysis. First, we're going to do it the most wretched, horrible way ever, so you know never to do it that way again. And then the next video is going to talk about how to do it simply. And then the third video is going to talk about some interesting applications with this, as well as extrapolations from this.